I welcome all for the last day of our FDP. Before watching this video, I request all to go through the PPT shared in WhatsApp group that contains a detailed view about hard disk drive. An outline of my presentation for day 5 includes important terms that come under hard disk drive, problems, disk scheduling algorithms, problems using disk scheduling algorithms. Let us see few important terms. Seek time. It is the time taken by the read-write head to reach the desired track from its current position. Rotational latency is the time taken by the sector to come under the read-write head. Data transfer time is the time taken to transfer the required amount of data, and it depends upon the rotational speed. Controller time is the processing time taken by the controller. Average access time is equal to seek time plus average rotational latency plus data transfer time plus controller time. Disk response time is the average of time spent by a request waiting to perform its I/O operation. Here we have to note one thing while solving problems. Suppose if the seek time and controller time is not mentioned, then we need to take those values as 0. And if the amount of data to be transferred is not given, then we need to assume that no data is being transferred. Coming to the problems. Consider a hard disk with 4 surfaces, 64 tracks per surface, 128 sectors per track, 256 bytes per sector. What is the capacity of the hard disk? The hard disk capacity can be calculated by using the formula surfaces into tracks per surface into sectors per track into bytes per sector. The values were given in the problem. There are 4 surfaces, 64 tracks per surface, 128 sectors per track and 256 bytes per sector. Just substitute all the values that were given. Now 4 can be represented in terms of 2 power 2. Similarly 64 can be represented as 2 power 6. 128 can be represented as 2 power 7. 256 can be represented as 2 power 8. Since the bases are same, the powers can be added. So after adding, we get 2 power 23. This 2 power 23 can again be written as 2 power 3 into 2 power 20. 2 power 3 is nothing but 8 and 2 power 20 is nothing but 1 MB. So 8 into 1 MB is equal to 8 MB. This is the value of disk capacity. Next problem. The disk is rotating at 3600 rotations per minute. What is the data transfer rate? Data transfer rate is equal to number of rotations per second into track capacity into number of surfaces. It is given that in 1 minute 3600 rotations are made, which means that in 60 seconds, because 1 minute is equal to 60 seconds, therefore in 60 seconds 3600 rotations are made. We need to compute how many rotations are made in 1 second. So it can be computed by dividing 3600 by 60. If we divide, we get 60 rotations. Hence, in 1 second, 60 rotations are made. Now, data transfer rate can be computed, which is equal to 60 into, for track capacity, just multiply sectors per track and bytes per sector values. So, we get 60 into 128 into 256 into the number of surfaces were given in the problem is 4. Now 60 can be represented as 15 into 4. 4 is nothing but 2 power 2. Then 128 can be written as 2 power 7 and 256 can be written as 2 power 8. 4 is available. 4 can be written as 2 power 2. This is equal to 15 into 2 power 19. If we add the powers, we get 2 power 19. Power 20 is equal to 1 MB. So for converting into 1 MB, just multiply by 2 and divide by 2. This is equal to, when 15 is divided by 2, we get the value as 7.5 into 2 power 19 into 2 is nothing but 2 power 20. 2 power 20 is 1 MB. 1 MB into 7.5 is nothing but 7.5 MB. Therefore, data transfer rate is equal to 7.5 MB per second. Next problem. The disk is rotating at 3600 rotations per minute. What is the average access time? Average access time is equal to seek time plus average rotational latency plus data transfer time plus controller time. In the given problem, seek time is not given, data transfer time is not given, then controller time is not given. So we can take all those values as 0. Therefore, average access time is equal to average rotational latency. Now, the disk spins at 3600 rotations per minute. So it takes 1 by 3600 of a minute to make one revolution. This is nothing but 60 seconds divided by 3600 rotations per minute. 1 by 60 seconds is equal to 1 by 60 into 1000 millisecond. We are converting seconds into millisecond. We know that 1 second is equal to 1000 millisecond. Therefore, 1 by 60 is multiplied by 1000. 1 by 60 is equal to 0.01667 and already we have 1000. After multiplying these two values, we get the value as 16.67 millisecond. Average rotational latency is equal to, the value for rotational latency is found as 16.67. We need to find the average rotational latency. For computing average rotational latency, just divide the value by 2. So 16.67 divided by 2 will be 8.33 millisecond. Therefore, average access time is equal to 8.33 millisecond. Let us see disk scheduling algorithms. Disk scheduling is done by the operating system to schedule I/O requests arriving for the disk. Disk scheduling is also known as I/O scheduling. The following are the algorithms we are going to see today. Let us see FCFS disk scheduling first. It is the simplest of all the disk scheduling algorithms. The requests are served in the order of arrival. Advantages: It is simple, easy to understand and easy to implement. It does not cause starvation to any request. Disadvantages: it results in increased total seek time. It is inefficient. This is an overview about FCFS. Let us see how to solve the problem using FCFS disk scheduling algorithm. Given the cylinders are numbered from 0 to 199, which means that there are 200 cylinders. Let me represent the number line. The number line should contain the given cylinder numbers arranged in ascending order. The range of the number line is marked 0 as the initial value and 199 as the final value, because it is given in the problem as the cylinders are numbered from 0 to 199. Now, let me arrange the request for cylinder numbers in the number line. After 0, 14 is represented. Then 41 is represented. We need to represent 53 because from the problem it is given that the head is initially at cylinder number 53. Hence 53 must be represented in the number line. After 53, 65 is represented. Then 67 is represented. After 67, 98 is represented. After 98, 122 is represented. After 122, 124 is represented. And after 124, 183 is represented in the number line. This is the way how to arrange the given cylinder numbers in ascending order in the number line. The problem states that initially the head is at cylinder number 53. So, let me mark here for 53. FCFS means first come, first served. That is, the request that arrived first will be served first. In the problem, the first request is for cylinder number 98. Hence, from 53, the head will move to 98. The next request is for cylinder number 183. Now, the head moves from 98 to 183. The next request is for cylinder number 41. Now the direction is reversed and the head will move from 183 to 41. The next request that must be served is for cylinder number 122. Now the direction is reversed and from 41 the head moves to 122. The request has arrived for 14, so the head moves to cylinder number 14. Then the request for 124 will be served. After 124, the request has arrived for cylinder number 65. Hence, the head moves to 65. And at last, the request is for cylinder number 67. The head moves from 65 to 67 now. This is the way how FCFS disk scheduling algorithm works for the given problem. To find the total number of head movements in every direction, find the difference between highest value minus lowest value. and add all the resultant values in every direction. For example, if we take this direction, the highest value is 183 and the lowest value is 53. Hence, subtract lowest value from the highest value. That is 183 minus 53. Then add this with the highest value minus lowest value in the other direction. So it will be 183 minus 41. Similarly, we proceed for all the directions and finally we get the following. This is the way how computation is done, and if we add all, we get the final result as 632. Therefore, total head movements for the given problem using FCFS disk scheduling is equal to 632. For all the other algorithms, I will explain the diagram directly. Drawing number line is similar in all the algorithms. There you have to mark the range according to the problem. Say for example, if there are 100 cylinders, then the number line should be in the range 0 to 99. Only for servicing the requests, we use different strategies employed in those algorithms. Let us move to the next concept. Let us see SSTF algorithm. Shortest seek time first. It selects the request with the least seek time from the current head position. That is, the requests having shortest seek time are executed first. The seek time of every request is calculated in advance and they are scheduled according to their calculated seek time. Coming to the advantages, it reduces the total seek time when compared to FCFS. It provides increased throughput. It provides less average response time and waiting time. Coming to the disadvantages, there is an overhead of finding out the closest request. The requests which are far from the head might suffer starvation. And switching the direction of head frequently slows down the algorithm. These are all the advantages. And this is an overview about SSTF disk scheduling algorithm. Let us see a problem on SSTF. This is the given problem. A disk with 100 cylinders are given. We can number that from the range 0 to 99. Then arrange the requests in ascending order. The head is initially at cylinder 50. Let us see how this is represented using SSTF algorithm. This is the representation. Let me explain. Initially, the head is at position 50. In SSTF, the closest request to the initial head position is 34 and not 73, because if we compute the difference between 73 and 50, we get the value as 23. But if we compute the difference between 34 and 50, we get the value as 16. Hence, the request for 34 will be served, then the request for 20 will be served, then the head moves to 19, the head moves to cylinder number 15, then to 10, 7, 6, 4 and 2. In the request, Still 73 is not served. 73 alone is in pending. So from 2, obviously 73 will be served. This is the way how SSTF works for the given problem. Let us find the total head movements. Total head movements is subtract 2 from 50, then subtract 2 from 73. The value will be 48 plus 71, which is equal to 119. In the given problem, the time taken to satisfy all requests must be calculated. The time taken to move from one cylinder to the adjacent one is 1 millisecond. Therefore, the total time taken to serve 119 requests is equal to 119 into 1, which is equal to 119 milliseconds. Suppose if the time taken to move from one cylinder to the adjacent one is given as 2 milliseconds, then we need to multiply 119 by 2. This is the way how the time taken for all the head movements are computed. Let us see scan algorithm. Here, the disk arm moves into a particular direction and services the requests coming in its path. After reaching the end of the disk, it reverses the direction and again services the request arriving on the path. This algorithm works like an elevator, and hence this is known as an elevator algorithm. Advantages: it is simple and easy to understand and easy to implement. It does not lead to starvation. It provides slow variance in response time as well as in waiting time. Disadvantages: it causes long waiting time for the cylinders just visited by the head. It causes the head to move till the end of the disk even if there are no requests to be serviced. This is an overview about scan algorithm. Let us see how to solve a problem. This is the given problem. We need to know the direction of head movement. Here it has been insisted that the head has to move towards larger cylinder numbers. Hence from 53, it has to service the cylinders in an increasing order. That is, 65 will be served, then 67 will be served, and etc. Let me represent the diagram. The head is initially at 53. The head will then serve the requests 65, 67, 98, 122, 124, 183. Next, the head will reach the end. The end is 199. And it will start moving to the other end of the disk, servicing the requests 41 and 14. Since there are no requests, the head will be stopped here. Now let us find the total head movements. Total head movements is 199 minus 53 plus 14 minus 199. sorry, it is 199 minus 14. If we add the values, we get the final answer as 331. This is the way how the scan scheduling algorithm works. Let us move to the next algorithm, CSCAN. Circular scan is an improved version of the scan algorithm. The head starts from one end of the disk and moves towards the other end, servicing all the requests that are in between. After reaching the other end, the head reverses its direction. It then returns to the starting end without servicing any request in between. Advantages: it provides uniform waiting time. It provides better response time. Coming to the disadvantages, it causes more seek movements when compared to scan algorithm. And also it causes the head to move till the end of the disk even if there are no requests to be serviced. This is about CSCAN algorithm. Let us see a problem. The head is initially at 53. The head moves from 53 to 65, 67, 98, 122, 124, 183, then 199. When the head reaches the other end, it immediately returns to the beginning of the disk without servicing any request. When it reaches from one end to other end, no requests are serviced, and now it starts servicing the requests 14 and 41. This is how CSCAN scheduling algorithm works. Let us compute the total head movements. Total head movements will be 199 minus 53 plus 199 minus 0 plus 41 minus 0. And the final answer will be 386. This is how CSCAN scheduling algorithm works. Let us move to CLOOK algorithm. This is similar to scan scheduling algorithm. The disk arm, in spite of going to the end of the disk, goes only to the last request to be serviced, and it reverses its direction from there. That is, it reverses its direction from the last request. It prevents the extra delay which occurred due to unnecessary traversal to the end of the disk. An advantage is, it does not cause the head to move till the ends of the disk when there are no requests to be serviced. It provides better performance when compared to scan algorithm. It does not lead to starvation as well. And coming to the disadvantages, there is an overhead of finding the end request, and it causes long waiting time for the cylinders just visited by the head. This is an overview about CLOOK. Let us see how to find the total head movement using CLOOK algorithm. Here is the diagram. Initially, the head is at cylinder number 53. Now, the requests 65, 67, 98, 122, 124 and 183 are served. Now, CLOOK algorithm, without reaching the other end, other end is 199. Without reaching that end, the disk arm reverses its direction. While reversing its direction, it services the requests 41 and 14. This is how the CLOOK scheduling algorithm works. Then the total number of head movements is 183 minus 53 plus 183 minus 14. This is equal to 299. So this is the total head movement using CLOOK scheduling algorithm. Let us see CLOOK algorithm. It is an improved version of the CLOOK algorithm. Head starts from the first request at one end and moves towards the last request at the other end, servicing all the requests in between. After reaching the last request, the head reverses its direction. It then returns to the first request at the starting end without servicing any request. Advantages: it does not cause the head to move till the ends of the disk when there are no requests to be serviced. It reduces the waiting time for the cylinders just visited by the head. It provides better performance as compared to CLOOK algorithm, and it does not lead to starvation. Disadvantages: there is an overhead of finding the end requests. Let us see a problem. For the same problem, let us find the total head movements using CLOOK scheduling algorithm. And here is the diagram. Initially, the head is at cylinder number 53. Then the request for 65, 67, 98, 122, 124 and 183 will be serviced. After servicing, the head moves directly to cylinder number 14. In this direction, 183 is the last request. Hence, CLOOK algorithm will not move to 199. It will directly reverse its direction and it moves to 14, and then 41 will be serviced. This is how CLOOK algorithm works. Let us find the total head movement. Total head movements is equal to 183 minus 53 plus 183 minus 14 plus 41 minus 14. This is equal to 326. That's all for today's session. In the 5 days FDP, I hope that I have made few justice to the title Operating System, a step into problem solving for NetSet. I request all to practice more and more different problems for cracking exams. Let me deliver my vote of thanks. Thank you is the best prayer that anyone could say. Now I take the opportunity to put all gratitude into words. First and foremost, I thank the God Almighty for having made everything possible. I express my sincere thanks to the management, Reverend Sister Secretary, Reverend Sister Principal, and all from our institution. I am greatly thankful to all the enthusiastic and energetic faculties, 136 registered faculties from various states like Tamil Nadu, West Bengal, Karnataka, Andhra, Telangana, Haryana, Manipur, Nagaland, Puducherry and Bihar. Once again, I thank you all and I wish you all success.